Tanya, an OpenSciEd teacher and facilitator. I'm here today to chat with you about Lesson 3 of the Metabolic Reactions unit. Here is when we get to have our first hands-on investigation of the whole unit. And I'll be honest with you, the first time I taught this lesson, I struggled through some of the parts of this actual investigation, so I'll make sure to take some time and give you any tips and tricks that I've figured out over the years. But before we jump into this lesson, let's pause for a moment and try to remember how we got here from Lesson 2. So, in lesson 2, we figured out that McKenna's small intestine looks very different from a healthy person's, and also the food isn't disappearing from her small intestine like a healthy person's does. That left us wondering, what is happening to the molecules that seem to be disappearing from a person's small intestine? Let's look a little closer at the lesson at a glance. This is a 2-day investigation lesson with about 60 minutes of material preparation in advance. There are 2 videos to help you with this setup. It is a hands-on investigation, but no devices are required. In this 2-day lesson, you'll see that there are 4 key moments to enhance student coherence. As we look at the 2-day lesson, we can see that it appears to be broken down into 3 major chunks. The first chunk happens on the first half of day 1. The second chunk happens at the end of day 1 and beginning of day 2, which leads us into our third chunk at the end of day 2. Let's look closer at day 1. The first sense-making chunk happens within about the first 20 minutes of class. Here the students navigate to today's lesson from their wonderings from lesson 2. They plan out their investigation on how they can figure out why the food molecules seem to be disappearing. They evaluate the use of the dialysis tube as a model for this investigation, and they decide that the dialysis tubing will be a suitable replacement for the human small intestine so we can conduct our investigation. This leads us to the second half of day 1, where the students start their second major sense-making chunk and actually complete part 1 of the investigation. They end the day by making predictions about what will happen when their dialysis tubing sits overnight. This leads us into day 2 when they finish the sense-making chunk by completing the investigation, collecting their data, and analyzing and interpreting their findings. From this investigation, the students figure out there must be tiny holes in the dialysis tubing since some of the food molecules, specifically glucose only, is found outside the tube in what was just pure water the night before. Knowing that the tubing represents the small intestine, the students take this information and apply it to what's been happening, but they're still left wondering why the starch didn't pass through. This leads us to the second half of day 2, where the students begin their last sense-making chunk of the lesson. Here the students are now wondering if it could be because the starch is larger or different shape, and they decide they want to see what starch and glucose actually look like. So they look at molecular representations of both. They confirm that the glucose is much smaller than the starch, and they can see that they're both made of the same type of atoms, which are carbon, hydrogen, and oxygen. The students add their findings to their progress tracker and begin to wonder about what's happening to the molecules that don't actually get absorbed into the body. So what they've figured out at this point is the food molecules are not actually disappearing. Some are moving through the walls of the small intestine and being absorbed by the body. Glucose is a small molecule and starch is large, and that's why only the glucose seems to be able to pass through the walls. And absorption means that molecules are moving out of the small intestine and into the body, or moving from one place to another through something. Let's dig a little deeper into those key moments that were identified in the lesson overview. In part 2 on day 1, you start to plan out your investigation to see why some food molecules seem to disappear from the small intestine. It starts by discussing why it would be difficult to use a real human small intestine, and it leads us to a conversation about how scientists will often use different substances that have the same properties as the original substance to do investigations. You then introduce your students to dialysis tubing, which is a specialized medical material that is used to represent the small intestine. Make sure not to tell your kiddos at this point that there are tiny holes in the tube, because that's what they're going to be figuring out on day 2 of the investigation. As you're discussing the setup of the system, you may want to start to build out your word wall at this point and add that glucose and starch are 2 types of food molecules. These definitions will grow over time, but it's a good way that students can see how definitions can build as we gain more information. I'll be discussing the actual investigation itself in the tips and tricks portion, but after it's completed, on day 2, on part 8 is where we're going to see our next key moment. This is where the students are starting to process what their data actually means. This is a very short section, only about 5 minutes long max, but it's really important to give your students this time before asking them to move on to whole group in part 9. Here, either independently or in partners, the students start to process that only glucose was able to pass through the dialysis tubing, which is our small intestine. So this confirms that it's not actually disappearing, but just moving. So there must be tiny holes that we can't really see. This brings us to part 9, where the students in whole group are now discussing what they think is happening. At this point, the students may be using the word absorption, and it's a great opportunity to decide on what they think it means at this point. The definition will build over time, but as of right now, we're just talking about the small intestine, so that's where their definition may stop. The students still can't explain why the starch didn't move, so they think it might be bigger or a different shape or simply getting stuck. This brings us to wanting to see what glucose and starch look like. In part 10, the students look at a model showing a glucose molecule and a starch molecule. Glucose being a very small molecule and starch being hundreds of times larger. This is a great place to add the words glucose and starch to our previous definitions on our word wall. What the students figure out here will be revisited in future lessons, so it's important that they understand the connections between glucose and starch. So where do we go from here? At this point, we are now wondering what actually happens to those large molecules that don't seem to pass through the small intestine. Do they get absorbed? Does the body just get rid of them as like waste? And this is what leads us to the next lesson. Let's look into some materials management and tips and tricks. So for the investigation, I have several suggestions for you. First, make sure the dialysis tubing has had enough time to soak before having the students work with it. The tubing is often difficult to open, so you may wish to practice in advance to figure out the best way to open it so you can assist your students better. In the past, I would also create a demo setup for each one of my classes to go along with the students' investigation, just to allow for some additional data points that they'll be able to use. Another tip I've seen teachers use, but I've never actually tried it myself, is using binder clips at the end of the tubing instead of trying to tie the tubes. Like I said, I've never tried it, but I've heard it works well. You may want to try the indicators with the solution that you're giving to the students that you're putting inside the tubing before you actually give it to them, just to make sure that there's enough of the starch and glucose inside the tubing to make the indicators react. This also helps you figure out how warm the water has to be for your Benedict solution to react. You may want to consider how you'll be getting this warm water to your students on day 2 in advance, because running around the classroom with a hot pot of water is sometimes difficult to do. I have also used the setup videos without sound in the past to show all of my students in one place at one time how exactly they're supposed to be tying the dialysis tubing and working together in pairs to make sure the entire thing is set up. Finally, I would suggest going really slow with explaining how the indicators work and what they're looking for, because the color changing and which color goes with which tube sometimes becomes a little complicated. In terms of word wall management, you're adding at least 3 words to your wall today, that being absorption, glucose, and starch. But there are other words that we encounter, like dialysis tubing, iodine, Benedict solution, food molecules indicator. You may wish to choose these, or your students may want to choose these to add to your word wall as well. That's up to you guys in your class. In terms of poster management, the word wall will be referenced, and then materials that are created during this lesson would be the dialysis tube diagram, which is going to be created on a large sheet of chart paper, and the investigation student handout itself. There aren't really any materials that are created in this lesson that need to be carried over into future lessons in terms of posters on the wall. And that's it for lesson 3. Now that we know what's happening to the particles and that they're not just disappearing, we're going to take what we learned from today and try to figure out what's happening to the food particles that are left over. Have a good day.